For years, theorists have suggested that Mars once contained the necessary requirements to support life. Now, NASA's Curiosity rover may have finally found indication of this from images showing what appear to be fossilized microbial structures. Over the past 5.5 years, NASA's Curiosity rover has been mapping and imaging the Martian surface to gain more insight on the dusty planet. In addition to snapping pictures, the nomadic vehicle has been searching for signs of water, while also determining the viability for human colonization. Scientists know that water once flowed on Mars and have been on a quest to discover whether it still does to this day. Aside from ice caps on the Martian poles, evidence of water in Mars's past can be seen in dried lake beds, gullies, and what was once a large ocean in the planet's topography. In recent images of the Gillespie Lake outcrop in the Yellowknife Bay area, Curiosity sent back pictures of small stick-like formations in a segment of sedimentary rock. To the untrained eye, these formations might not appear to be much, but to a microbiologist who has studied microbially-induced sedimentary structures, MISS, the pictures seem to have some profound implications. Nora Nofk of Old Dominion University in Virginia meticulously compared the photo to instances of myths on Earth and published a paper that has intrigued scientists at NASA. Though she's hesitant to make any definitive claims, her paper provides some of the best evidence to date for indications of past life forms. The stick-shaped markings aren't actually considered to be fossils of microorganisms themselves, but rather fossils of their imprints. Some have contested that these tubular markings are more likely crystals rather than the footprint of microorganisms. In either case, the finding shows that the area once consisted of a body of water that had elements needed to support life. NASA is planning on sending another rover that is nearly identical to Curiosity, with the goal of strictly searching for signs of previous life. Once collected, samples will be sent back to Earth from a small rocket deployed from the rover. Scientists have recently found other signs of life on the Red Planet, including fluctuating levels of methane in the atmosphere. Some have proposed the idea that this gas may be coming from life below the surface. On Earth, methane is produced from bacteria, primarily in the stomachs of animals and humans. Could there be bacteria or life containing bacteria producing that methane below the Martian surface? Conspiracy and speculation erupted across the internet over an alleged volcanic plume stretching roughly 1,200 miles across the Martian atmosphere. The plume appears to originate from the planet's supposedly dormant Ursa Mons volcano. Images of the activity were taken on September the 24th by the Mars Express orbiter and later published by the European Space Agency. According to NASA, volcanic activity on the Red Planet ceased some 50 million years ago after the Earth's Cretaceous Paleogene event that killed off the dinosaurs, but some believe this latest imaging shows otherwise. Spurred by conjecture from a popular YouTube conspiracy channel, claims of volcanic activity on Mars reignited theories of government cover-ups and strange happenings within NASA, the FBI, and other controversial government agencies. Many are pointing to last month's Sunspot National Observatory shutdown, the switch to a limited safe mode on the Hubble and Chandra telescopes, and the sudden failure of NASA's Mars Curiosity rover as evidence that strange events occurring on the planet may be intentionally obfuscated. Ursa Mons is located within a tightly situated line of volcanoes on Mars, collectively known as Tharsis Montes, which lies in the shadow of Olympus Mons, the largest volcano in our solar system, more than twice the size of Mount Everest. Ursa Mons happens to be the planet's second largest volcano in terms of volume and is home to a series of caves NASA has studied as the best places to situate research and habitation modules. Could there be something already underway? This project developed a revolutionary system to exploit the novel idea of extraterrestrial cave use stated a project summary published in 2004, further explaining that 2 missions were tested to gather data. Ursa Mons is known to have an annual weather phenomenon in which sunlight warms the area around the volcano, bringing small amounts of dust into the air. Rising air currents bring the dust and other fine sediment above the volcano's caldera into a thick, spiraling cloud that is big enough to be seen by a probe orbiting the planet. But the latest plume looks nothing like the spiraling cloud recorded from this phenomenon in the past. Instead, it appears as more of a streaking trail that's persisted over the course of weeks. NASA has attributed the plume to water ice clouds that are gathering over the volcano. The agency says that at a certain time of the year, the small amounts of water in the atmosphere freeze and condense near areas of high altitude, notably above this volcanic region. If this is the case, then maybe there's significantly more water on the red planet than previously believed, and we should study the areas it's sublimating from. But then again, there's always some simple explanation from NASA that seem to make everyone's concerns seem trivial. Is this really just a storm, or are they covering up something far greater? Advancements in the fields of astrophysics and biology have put both scientists and the public on the edge of our seats, hoping we're on the precipice of discovering definitive proof of extraterrestrial life. And whether your reaction to that statement is, "Come on, we've already found extraterrestrial life and it's walking among us," or, "Yes, it probably exists. Now, the government might make it a priority to give you that proof," or, if you ascribe to the former belief, disclose it to you. At least that's what a congressionally mandated report to NASA publicized recently, urging the space agency to prioritize the search for extraterrestrial life in every single one of its missions, a proposition we could really get behind. The recommendations were based on a confluence of recent findings, including discovery of a multitude of exoplanets in the habitable zone of other star systems, the existence of subsurface life on Earth in its early days, and its potential existence on certain moons in our solar system, and possible technosignatures of advanced technology seen in fluctuations of observed light from the distant stars and the bizarre FRBs. The proposal came from nearly 40 scientists representing top astrobiology and space studies programs at esteemed universities and institutes around the US. It was presented by the National Academies of Science, Engineering and Medicine, NASEM, at a public briefing in Washington, D.C. Lead scientists presenting the project acknowledged their framework needed to implement a broad scope and that a successful search strategy needs to integrate 3 core tenets: that no one biomarker sign of life is infallible, no single geochemical scenario or environment is the key, and that life elsewhere may not be as we know it. They also noted that outside-the-box thinking would be necessary to realize their strategy. To advance the search for life in the universe, NASA should accelerate the development and validation in relevant environments of mission-ready life detection technologies. In addition, it should integrate astrobiological expertise in all mission stages, from inception and conceptualization to planning, development, and operations. One of their other recommendations was based on the existence and development of subsurface life on our planet in its early days, leading biologists to believe that similar bioevolutionary mechanisms may be happening or have already happened on other planets. NASA's program and missions should reflect a dedicated focus on research and exploration of subsurface habitability in light of recent advances demonstrating the breadth and diversity of life in the Earth's subsurface, the history and nature of subsurface fluids on Mars, and potential habitats for life on ocean worlds. Their paper delivered 9 recommendations and 25 findings that will hopefully ignite a fire under NASA to give us proof of extraterrestrial life that we deserve. After all, it would be one of the most profound discoveries ever made by humankind. Why wouldn't we make it a priority?